Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, grade 6. Today we are talking about lesson 2, law of levers. We have learned definition of levers is rigid bar, straight or curved, that rotates around a fixed point called fulcrum and is affected by effort force and resistance force. What is meant by force arm? Definition of force arm is the distance between the effort force and fulcrum. Effort force, the distance between effort force and fulcrum called force arm. Force arm, distance between effort force and fulcrum. Second, resistance arm is the distance between the resistance and fulcrum. Resistance force, the distance between resistance and fulcrum called resistance arm. Right scientific term is the distance between the effort force and fulcrum called force arm. Is the distance between the resistance and fulcrum called resistance arm. So, law of levers equal effort force times its arm equal resistance force times its arm. Effort force or resistance force unit Newton. Force arm or resistance arm unit centimeter or meter. For example, effort force equal 2, the force arm 5, resistance force equal 1. Calculate the resistance arm. Effort force equal 2 times 5, the force arm, equal resistance force equal 1 times resistance arm. The resistance arm equal 2 times 5 divide 1 equal 10 centimeter. Law of levers and conservation of effort. We have learned types of levers, 3. First class lever, second, third. First class lever, the force arm is shorter than the resistance arm. Force arm shorter than the resistance arm. The distance between effort force and fulcrum called force arm shorter than the distance between resistance force and fulcrum called resistance arm. Force arm shorter than the resistance arm, so the effort force is larger than the resistance force, doesn't save effort. 2. The force arm is equal the resistance arm. Force arm equal the resistance arm. The distance between effort force and fulcrum equal the distance between resistance and fulcrum. So, the effort force is equal to the resistance force, doesn't save effort. 3. The force arm is longer than resistance arm. Fulcrum, force, resistance force. The distance between effort force and fulcrum longer than the distance between resistance force and fulcrum. So, the effort force is smaller than the resistance force. Save effort. When the force arm is longer than resistance arm, save effort. Second class levers. The force arm is longer than resistance arm. The force arm is always longer than resistance arm. The distance between effort force and fulcrum longer than the distance between resistance force and fulcrum. So, the effort force is smaller than the resistance force. Save effort. Second class lever, always save effort. Third class levers, the force arm is shorter than the resistance arm. the distance between effort force and fulcrum shorter than the distance between resistance force and fulcrum. So the effort force is larger than the resistance force, doesn't save effort.